Hello, my name is Babajide Ibiayo from Lagos, Nigeria. I am a student of the Micro Masters in Data Science by at the ADA Academy, and I'm working on the statistical analysis of the built-in air quality data set that is built in R. And I have in front of me the exercise 5.1, which is to compute the correlation analysis. Okay, basically we'll be computing the Pearson correlation between the ozone variable, and each of the other variables like solar wind and temperature using our cleaned data set. I'll be in this recording, I'll be showing you the process and my thoughts in executing and solving this exercise. Thank you very much. Let's get to it. All right, so first of all, I'm going to classify the strength of the Pearson coefficient R based on standard statistical thresholds. All right, but I really am not sure again what they are, so I'll just quickly find that out from Google and just say what are and then guess that's what they are, and I can put them in my markdown, and that will be so for strong, that the coefficient has to be greater than 0.5. Okay, so we'll say R greater than 0.5, right? So then we can do for moderate. Okay, so moderate would be 0.3, right? 0.3, and that would be, and that means R would be between them, between 0.3 and 0.5. And then for the weak category, and then obviously R will be greater than 0.5. I think, oh no, sorry, less than. Okay. Less than 0.3. All right. Yep, I think, yes, I think we got it. That's that. Okay, so now that we have this, I think the next step will be to insert a chunk. And you can insert a chunk using Control Alt I on Windows, or maybe Control Option I on Mac. I'm not sure. I use Windows, and we'll basically give the chunk an ID. So let's just call this correlation analysis. And then we're also going to set echo to false because I don't want to, you know, necessarily show the code that we're writing in this chunk because it's going to be hidden. I'm going to just have some helper functions and do some calculations here in order to be able to output a table. Okay, so now that I have this, I can now begin to get the correlation between ozone and each of the other variables as it is said here. All right, so the first one would be, say, R solar, and that will be, we'll use the correlation method, and that would take our data set, aqua AQ clean, all right, and we'll specify the ozone, all right, and solar, and then we also need to specify a method, and that method would be Pearson. Okay, so I think I can make this bigger. We don't need to be seeing that so that everyone can. Then I can don't know why my duplication thing isn't working. Keep trying it, but it's not working. So just copy this. Copy 3 times. So this will be for wind, and I can change this to wind. Oh no, not that, not the ozone, this one to wind. All right, and then this one will be temperature. And this one would be temp. Okay, so let me just make sure that we have some reasonable values. Or just, just I always like to check just to be sure that my code is running, and I'll try and run this chunk. Okay, so I'll run this chunk and see if I get any error. Our object not found. Where is that coming from? Oh, okay, sorry, that's here. Okay, so I'll run it again. Okay, so yeah, so we get some values, so that is fantastic. Okay, so now I can see there's some negative values here. So now we need a helper function that would take that value and print whether it is the strength and the direction. Okay, so it will take a value and output the value of the strength or direction as labels, because we're going to need that So rather than hard coding it or writing it, I'll just put all that code in a function. So I'll just call the function get interpretation. All right, and that's going to be a function that takes an R value as input and takes an R value as input, and we're going to do some comparison. So first of all, I'm going to do for the direction, all right, and I'm going to say um, direction, and I'll use the if else. So if R is greater than 0, then it's positive. If it is not, then it's negative. Okay, and for the um, sorry, this AI thing, for the strength, for the strength, well, since for the strength, since we probably might have negative values in the coefficients, I think it would be best to create to get the absolute value for strength comparison. So I'm going to say absolute R will be absolute value of ABS of R, and that's to make sure that the negative sign isn't involved. And then I can now say strength, create a variable called strength, and I can use, rather than if else, I think I'll just use case when, and if ABS R is greater, all right, greater than ABSR is greater than 0. Sorry, 0.5, then we can say strong, and if ABS R is greater than 0.3, I can say moderate, and then well, true will be weak. Okay, so then we can now return the value, paste, and that will be the strength and the direction. Okay, All right. Well, as usual, I like to test quickly this function by just passing in something. So if I say get interpretation and I pass in um, r underscore wind and then run the chunk, I get strong negative. All right. So I think it works. Um, if we pass in temp, run the chunk again just to see what we get. Strong positive. Okay, so I think something is working. So I'll leave it like this. I'm comfortable. The next step after testing this is to build the summary data frame that we will use for as input to build the the table. All right, so I can say core summary, and that would be the data frame. All right, now this data frame will consist of the let me flip to the assignment just to see what. Okay, so we're going to be doing ozone versus solar, ozone versus wind. All right. Okay, so let's call this variable name. Okay, and I'm going to make this equal to a vector, and that vector I'm going to just call this one ozone versus solar r, and the other one will be sorry, ozone versus wind. You get the idea. And ozone versus temp. Okay, so that would be temp. Okay, I can flip this because now we will do for the R values. Let me make this bigger so that we can see properly. Now for the R and the R value, and that will be another vector, but we already computed that here, so I can just get it from here and match them up. So that would be r underscore solar, and this will be r underscore wind, and r underscore temp. Okay, because we already calculated them up there. Okay, so the final one will be the interpretation. So let's just call that interpretation. Okay, interpretation. Sometimes my spellings And I'm going to set that to another vector, but this time we have a function that gets the interpretation for us. So just going to call the get interpretation function, and I'm going to pass in each one. Our solar. Okay, so that's that one. Then comma, like that. Okay, so so that makes sense. So that's the table, and I need to put a comment here that creates the summary data frame, so that if I come back to this code later on, I'll understand what I'm trying to do here. So I guess the next step now would be to create a polished cable table with that data frame. But before I do that, I always like to see if I have the right value in you know in the variable that I just created, just like the small test. So I'm going to run this and see how that how the whole thing runs, and if there are no errors, I should guess. So yeah, we get something really nice. Yep, yep. I think we're good to go. So the test passes, and I can go ahead and create my table. All right, and we have the cable that we're going to pass in core underscore summary. All right, and we're going to define a couple of options. Okay, so the options we're going to pass in would be, if I can make this bigger. Inside here, we'll be passing in a caption, and I'm going to call it the person correlation between ozone and other weather variables. Well, I can modify that later, but that's what comes to the top of my head. And I don't want the video to be too long, so then we specify the alignment, let's say left, center, OCR. And I think that's about all we need. Then we can now pass this to the cable styling. All right, we can pass that to the cable styling. I mean, pipe it, sorry. Let's pass everything to the cable styling method. Like that, cable styling, and we'll use the bootstrap options. and we can set that to vector, and we'll just say stripped and um, over. Okay. Um, I'll just run this to see what we have and see what other optimization. Okay, so from what I see here, we might need to give more friendly names to the header, to the variable names, all right, and the column names. And we can do that easily over here by giving using the column dot names, and we can put all that in a vector, right? And I'll just use variable, variable name for the first one. Sorry, let's capitalize that. And instead of R value, I'll do correlation coefficient, right? And interpretation, excuse me. All right, so this should fix that. Another thing I noticed is that we should round the coefficient, correlation coefficient to 3 decimal places. Okay, so let's do that before we run the script, and we can do that here. Let me see where we have the R values. Yeah, all right. So we can modify this part of it a little bit. So I'll just modify that. Okay, and what we want to do is wrap that value in the round. All right, and that would be 3 decimal places. And we have to do the same for all this. So I'll just put 3 there, round, and for this one, I'll do the same. Sorry, 3 and round. Okay. Um, okay, so I think that should be it. Let's run it again. Let's just see if everything is argument 4 is empty. All right, there's a trailing comma. Have to round here. No, there shouldn't be a comma here, really. Okay. Um, Brackets are all good. I think this is all good here now. Let's run it again. Yep, I think we're good. Yes. Yes. So this is how it should be. Yeah. Right. And let's look at it when it's knitted. So I'm just going to run the knitting, and hopefully we should see it pop up. Yeah, there we go. So yeah, that's it. Looks really good. Right. So what's next would be to do this part of it, a brief paragraph using inline code for all values, comparing the three correlations, I think, the three correlations, and commenting on the direction and strength of each relationship. So, like an interpretation of everything we've done in a paragraph. All right. So, I'll take a break here, and when I come back, we'll have a look at it and do the last part of it, the interpretation. Thank you for watching thus far. All right, so interpretation. Okay, so before I write anything, I'd just like us to quickly look at this um, table. If we look at it, we can see that temperature has the most dominant linear relationship between with the atmospheric ozone, followed closely by wind, and obviously the solar has very little impact on the atmospheric ozone layer. However, it's interestingly we can see that the temperature has a very strong positive um, linear relationship with the ozone, indicating that higher heat or higher temperatures is strongly accelerates ozone concentration. Now, that in itself is what the data is telling us. All right. So when it's very, very hot, there is a likelihood of increased ozone layer. However, when there's a strong wind, because the wind has strong negative correlation with the ozone layer. So when there are strong wind bursts, it kind of clears or reduces the ozone. Okay, so in windy situations, the concentration of ozone depletes. However, the solar has the least impact on the formation of ozone. Okay, so while the sun is actually um, necessary for the formation of the ozone layer, the impact actually depends on other atmospheric variables such as the wind and the temperature. Right. So it's we can't say that real world impact is dependent on seasonal heat thresholds. Okay, so real world impact of the ozone layer is or ozone concentration or the amount of pollution is dependent on seasonal heat thresholds. Right now, having said that, I'm going to try and put that right in using R inline and state it. Okay, I'll be writing it out. So if you're bored, just fast forward the video from here and you can later on read my report. Okay. All right. Thank you. So I could say a comparison of the Pearson correlation coefficients reveals that, just like I said before, temperature um, has the most dominant, um, dominant, the most dominant linear relationship with with sorry, sorry, okay, relationship with um, atmospheric atmospheric ozone. Forgive my spelling. I think it's fine. Atmospheric ozone. Well, and say closely followed by temperature, by wind, and yeah, closely followed by wind speed. Actually, what's going on? Wow, this thing. Okay, closely followed by wind speed, while solar radiation um, displays the weakest link. Okay, so specifically, okay, specifically, um, temperature shares um, shares a um, and we're going to get that value right from our summary table or summary, right? And that would be post summary, and that would be temp, our temp. Okay, so shares. No, no, no. Okay, so it's the interpretation we actually need. So that would be interpretation. Interpretation, right? Interpretation, and that would be the first one, right? Shares a whatever that is, which I strongly think would be strong and positive, right? But I'll test it. Linear relationship. Okay, let me pause here. Let's test. I just want to see if this brings the output that we want. So I'm going to knit once again. Like I said, if this is already familiar with you, you can just, fast forward the video from here. Okay, so um, a positive linear shares a moderate positive. Yeah, it works. Moderate positive. That's it. Moderate positive. However, I would have loved um, is it moderate positive? Moderate positive seems to be. Oh, we're talking about temperature. Okay, guys, so it should actually be number three, right? Because that's the third. Um, the index should be three, and that's the index of the third row is the comparison for ozone and temperature. So that should be three. That is one. Then secondly, I need to make this capitalization into all lowercase so that it matches in the sentence. All right, so I'm going to have to change that here. Right, so I'm going to have to make this strong and this weak. All right, so with that correction, I'll knit once more just to be able to see it. Because I mean, even if I run the chunk, it's not in the chunk, so we won't say anything if I run the chunk. All right, so the only way to check would be to knit it again. And great. All right, so we have strong positive, so that looks good. Now let's make it bold. So I'm just going to add um, two asterisks before and after, and strong positive should appear bold. Okay, I'll need one more time. Trust me, this is it. After this one, we'll just continue writing now that we know that where things are. All right, so there we go. So we have strong positive in bold. So let's go on. So what else? What else? Um, Strong positive linear relationship with ozone. With ozone, and now we have to pull the coefficient out. value of the coefficient, and that would be core summary, a core summary table. All right, and we're not doing interpretation this time. We need the value, so that would be our value, and we're going to be accessing the same index, core summary $r value, and that would be at 3. All right, so that is this one. All right, but I'm going to round it to 1 decimal place. Okay, I'm going to round it to 1 decimal place so that it says 0.7 rather than 0.699. All right, so we can say round, sorry. Okay, so we can say round over there. I can make this bigger. I'm sorry about that. Okay, so we can say round, right, and put another bracket here. And this time I'll just say 1. Now I seem to have lost the, because it should show up in red. Okay, it does. Right, so this should work. Okay, unfortunately I have to knit again just to be sure there is no errors and I can continue. Okay, and I would love to put this in brackets. Just like that. Well, this is the reality. You just, this is the reality. You just write and then you have to test before you go on. So please be patient. Like I see, there's an error there because of what I just changed. It says unexpected comma, and let me make this bigger. Where is the comma? So I'm saying here that round that, comma 1. Okay, it's after the round 3. Okay, here. Oh yes, it shouldn't be there. Okay, this shouldn't be here. So the comma should be like this. Okay, and yes. All right. Sorry, guys. This is the reality. Okay, so I don't expect to have any errors now. I think we basically fixed it. Yes, we did. Great. So we have it. Ozone at 0.7. Now, look, me, I'm a perfectionist. So that should actually say R equals, all right, 0.7. So if I put an R equals and a space here, all right, that would make more sense. Okay, so I'm saying the ozone R coefficient. Okay, that's just what I'm saying. The ozone temperature R coefficient is R is equal to 0.7. I'm not going to knit again because there's no point. We could just continue. So, like I said, temperature shares, specifically temperature shares a strong positive linear relationship with ozone at R equals 0.7. indicating, right? Indicating that higher temperatures or higher temperature or heat. Let me use the word heat. Higher heat strongly, strongly accelerates. Can I use that word? Accelerates ozone concentration. Okay, and what the autocomplete AI is giving me some ideas, and is therefore a key factor in predicting. Well, I don't think I want to say that. Rather, so it doesn't make long. I can say conversely, on the other hand, okay, on sorry, on the no, you can't use that word. Sorry. Conversely, I think that is a better word. I don't know why R does this sometimes. And this blue thing, I don't know why it comes up. Conversely, all right. Conversely, um, wind speed, right? Wind speed, right? Features, all right? Um, let's say uh, a strong negative linear relationship. Should we say that? Is it really strong? At 6, 0.6. I would say 0.6, 0.7 is, well, anything above 0.5 is considered strong, but compared to the temperature, I think is moderate. Okay, so can I say a moderately strong negative? Well, I'll just say what is on the table. Strong. Well, now I need to put this again now. Now I need to put that the description wind speed features. I need to put that same description. I don't understand why this comes, and I don't want it to. When it's there, like this. So I'm just going to copy this, right? Because we can reuse it, and I'm going to change this to 2. We're talking about wind, all right? So it features that linear relationship. Linear relationship, all right? And again, I can copy exactly what we have here. Since we can reuse it, I don't have to do it again. Linear relationship, and I can just paste it here. And again, change this to 2. All right. Okay. Linear relationship. which mathematically, or is it statistically? Mathematically suggest. Oh, now this is autocomplete supports. That's not what I want to say. Which mathematically, I don't want to say all this. Which mathematically, because we have that, we've said that before in my earlier in my report, which mathematically supports, right? Observation. I've done this earlier in the earlier part of the report, which mathematically supports our observation. Okay, that higher wind velocities, just like I said before, that higher wind velocities or speed, I'll use velocities, higher wind velocities actively, okay, actively breaks up. That's what I was trying to describe to you earlier before we started writing. Actively break up, okay, or disperse. Should I use the word? Yes, break up and disperse. Break up and disperse, right? Localized air pollution. Wow. I hope I'm making sense. Okay. Now, all right, this should be Z. American. So finally, we only have the solar to do. All right. So I'm just gonna do the same thing. I'm just gonna say, okay. So finally, um, solar radiation. Solar radiation exhibits a much more, and again, sorry, can I make this big for your sakes? Again, a much more, and I'm going to copy this. Okay, so I'm going to copy this. All right, and going to paste it here, and this will be 1. I think it's that AI autocomplete thing that I'm going to find a way to turn it off. Honestly, I don't know how I enabled it. Maybe a keyboard when I was practicing the keyboard shortcuts. All right, so the much more R coefficient, or yeah, exhibits much more. Then obviously, then I'll do linear relationship. No, have I said that before? Exhibit a much more that linear relationship. And then we put the R coefficient. So that will be, I'm going to copy this again. And I'm going to paste it here. I am sure this is boring to you. I know that. I can tell it. I'm so sorry. But if you're still watching this video at this time, I say thank you. I doff my hat to you. Honestly. But if you already got the gist, you can just fast forward. All right. So confirming, okay, how that confirming. So I'll say confirming that um, while sunlight, all right, while sunlight um, is essential for, or is, while sunlight is essential for, is it air quality? No, is an essential catalyst. While sunlight is an essential catalyst, catalyst for ozone ozone formation. Ozone formation. It's um, individual. It's individual impact. All right. Is or is individual real world impact. I think that I should state that individual real world impact is lower and heavily dependent on seasonal heat thresholds, right? Heat thresholds. So it might be sunny, but if the temperature, it might be, the sun will come out, of course, because that's why we have day, all right? But it also needs high temperature, okay? Dependent on, and that is seasonal. So if for instance in New York, because New York, that's the what that data said is, if there is spring, okay, it's not as hot as summer, right? So and it is in the summer when there's high heat temperature that you have higher ozone layer concentrations and therefore poor air quality or degrading air quality and risk of a lot of pollutions. That's the bottom line for what my conclusions about and my report is all about, just to prove what I've just put here. All right. So that's the end for exercise 5. But before I go, we're going to do one more test just to meet so that my interpretation, I don't know, just to check it one more time and see that my interpretation makes sense. All right. And if we need any optimizations. Thank you for staying with me this far. It's over. All right, I'm gonna make this bigger, and I don't know if you can see this. Yeah. Okay. So everything looks good. Everything looks good, and so we'll end. I'll just show you how this looks um, from the beginning. So this is the report I've been doing, and this is how it looks. All right. So this is just the other part of it. I had a little issue with this graph, but if you read the report, I spoke about it here in the notes. All right. So thank you guys. That is exercise 5.1, and that's the video. I'm not going to bore you with the other exercises that is remaining because the video is going to be long. So thank you. And also, I want to encourage you. There is a cohort for MicroMasters for Artificial Intelligence coming up this June at the ADA Academy. I call it the ADA Academy, of which I am a student. And this video is part of my contributions to the, efforts of the academy. I strongly recommend this academy if you want to be a data scientist, you want to learn artificial intelligence, you want to actually learn by doing, then I suggest that you sign up. There will be a link to the registration right under in the description of this video. I'm positive. And you can also subscribe and get in contact with Prof. Adewale Olawale Awe, who graciously permitted me to do this video. Thank you very much and goodbye. Once again, my name is Babajide Ibiayo. Thank you for joining.